Hello, everyone. Thank you for coming to Lakeflow Connect, where we're going to talk about how we can help you eliminate hops in your streaming architecture with Zero Bus. So I'm Victoria. I'm a product manager, member of product staff here at Databricks, and I'm a PM on Lakeflow Connect, so all the things to do with ingestion. Before Databricks, I was at Tabular, so we were part of the Tabular acquisition, all things Apache Iceberg, and I was a PM there. And in my previous life, I was an engineering manager at Shopify, focusing on data ingestion.
Hi folks, my name is Nikola. I used to be a SQL Server engineer for a long time, and now I'm here, software engineer in Databricks.
So what we're going to do today is just introduce the concept of Lakeflow Connect and what that is. Then we're going to talk a little bit about the business trade-offs and technical trade-offs that you may be asking yourselves when building one of these ingestion pipelines for streaming, and then deep dive into some architecture designs that we see every day in the IoT, clickstream telemetry use cases. We're going to show you Zero Bus. How does this augment your architecture? We're going to do a demo in action and then finish up with some closing thoughts. So what is Lakeflow Connect? Lakeflow Connect is a unified intelligent data engineering solution built on Databricks. So all of this is built on top of our unified governance layer of Unity Catalog with optimized storage with Delta Lake, Parquet, and Iceberg. So those are our open standard of table and file formats. So Lakeflow has three pillars. There is Connect, which is everything to do with ingestion. There is declarative pipelines. So this is everything you need to do for your ETL. So this could be transformations. And then we have jobs for orchestrating those workloads, whether they are analytic workloads or AI workloads. So Connect, the goal of Connect is to provide ingestion solutions that are simple and low maintenance and are unified under our lakehouse architecture. And finally, it's efficient end-to-end to bring that that data in. So let's talk a little bit when we want to build one of these ingestion pipelines, the business and technical trade-offs that we encounter. So I'll talk a little bit about two, like maybe common use cases. Maybe you have these in your business. So maybe I want to have an ML recommendation system. I have something deployed, an ML recommendation system. It's making recommendations to my customers. I want to archive those recommendations for historical analysis to understand how well we were making those recommendations and maybe use them for training later down in the road. So I want to collect that historical data. But because this is a serving application, I want to get this data off of that serving app as soon as possible. Similarly, in a clickstream use case, maybe I want to run an A/B test. So I have edge devices like a mobile phone running an app or maybe a web browser. And I want to build a business dashboard so we can see the results of that A/B test. Now, the business, like the person looking at this business dashboard, maybe only checking it once an hour. They're not looking at it all times during the day. But from the front end, we want to offload those events quickly. So let's deep dive into a customer use case that we've been working on with Joby. So Joby is a completely vertically integrated business. They build their own aircrafts, and with these aircrafts, along with the manufacturing pipeline and their flight analytics, they're using all that data to improve the technology. They want to improve the device, they want to improve the aircraft, they want to improve the speed, and they want to be able to trace that data all throughout the path from the manufacturing to flight. So let's start with their architecture, but let's start at the business goal. So in the upper right-hand corner here, we have a business goal. I want some sort of dashboard. I want to build some sort of AI agent, maybe some transformations on my manufacturing data. Now, to get that data in today, Joby has several factories that are manufacturing different parts of the aircraft. Now, these factories operate independently. They have some sort of forwarding agent. This forwarding agent today pushes messages to a message bus. Then, now in the message bus, these messages are durable, and we can ingest these messages using Spark into our data lake. Now, there's a number of different challenges that Joby has here. So one is that every factory is different. They have a different purpose, they have different equipment. The machinery at each of these factories are different. They have different standards. The individual devices are coming from different manufacturers, and they may change over time. And finally, each independent factory site has their own limitations and requirements. They have different dependencies. This could be the internet reliability of the site. They can differ from place to place. So we want to be able to offload that data as quickly as possible. So we understand a little bit more of the Joby use case, but who is actually operating on this data? So I want to ask this question of like, who is the data operator here? And what is the time to action that's actually required for the business? So who is looking at the dashboard? So we want to build some sort of dashboard, and when are they looking at it? So I mentioned a business user is looking at the dashboard. When are they looking at it? Maybe a couple of times a day. Maybe we don't need some like real-time ingestion. Who is reacting to the pager? Maybe we have these events coming in, we want to page an engineer. Pager goes off, but it may take a minute or two for that human to like react and wake up, get their laptop, and fix the system. So we have a human looking at the dashboard, we have machines that are waking up humans, and machines that are maybe performing non-real-time analytics to understand the performance of the overall system. So the point that I want to make here is that we actually don't have any real-time operators on the data. So just to go over some of the telemetry business and technical constraints here, we have leadership who wants a dashboard, we have developers who want historical data, but on the technical constraints side, we have buffering constraints, so there's no real-time business need. But on the technical side, we want to offload this data as soon as possible. This could be due to reliability of the machines. These connections could be ephemeral. We could be missing this data if we don't offload this data quickly. So how can we offload this data quickly from the source? So let's dive into how people are doing this today with like IoT, clickstream, and telemetry architectures. So typically you add a message bus, you add some sort of staging area to make that data durable. So here's an example of a telemetry use case. So you may have a series of cloud applications that are pushing data to a message bus. You're ingesting that data with Spark into your data lake. And a clickstream use case looks awfully similar. You have these different kinds of edge devices, again, pushing data to the message bus, making it durable. You're using Spark or some sort of other ingestion tool to persist it in the data lake. And then finally, the IoT case that we went over with Joby. Now we have some sort of forwarder, again, pushing data to the message bus and then ingesting it. So we have this two-hop architecture across all of these different use cases. What problems does this create for us? So first of all, there's the operational complexity of now I have this middleware. I have this middle piece that I'm going to have to manage. But also the data is duplicated. We have data in the message bus as well as in the lakehouse that we need to govern. Things are getting really complicated. In addition, because we have this new component, this new piece of infrastructure, this is a new tool that your engineers are going to have to learn how to work with. So this creates additional complexity and additional skills required to do the job. So now we have more problems to solve. How can we reduce the data duplication, reduce architecture complexity, and offload this data quickly from the source? So I'm happy to announce, you probably heard this in the keynote, Zero Bus with our direct write API. So the goal of this Zero Bus architecture is that we streamline your ingestion at scale as part of a unified platform with Databricks. So you'll be able to have these producers, they could be these edge producers, they can be cloud applications, and instead of talking to a message bus, now you can talk directly to our service, our Zero Bus service. And it will take care of acknowledging the message, making that message durable, and persisting it in your data lake. There is no setup required. You just create a table and start pushing data. So just some overall key benefits and some stats here. So today, Zero Bus, our direct write API that we're offering, does not do real time, but we offer 5-second latency to get that data in. In terms of throughput, for every connection, we offer roughly about 100 megabytes a second of throughput. But we can support thousands of connections, all writing to the same table simultaneously. This completely streamlines your architecture. We've reduced operational burden. We've eliminated an additional hop that the data had to go through from source to sink. And because we eliminated this extra hop, there is no more data duplication. There's only one source for your data, and that is your Delta table within Databricks. This is all part of the unified Databricks platform, and because we've built this on top of Databricks primitives like Delta, it works seamlessly with the rest of the Databricks platform. So I want to talk about Soracom. Soracom has been a great customer that we've been working with. Soracom is a native IoT platform that helps accelerate innovation by handling the heavy lifting that's typically used that comes with connecting devices to the cloud. So this is a quote from Soracom. We can now push high fidelity data from devices around the world to the Databricks data intelligence platform using our cellular, satellite, and low power wide area network services to accelerate time to insights for game-changing results. So this greatly simplifies now for Soracom and Soracom's customers how they streamline data from any device around the world now to Databricks to get real insights. So a little bit of what the architecture looks like before. This was our multi-hop architecture. We had these producers, both cloud applications, edge devices, factory site forwarders, pushing data to a message bus. Now, we've eliminated the message bus. We've eliminated those ingestion jobs that you had to manage before. Now you just push directly to zero bus, no setup. The data is materialized in your lakehouse. So let's jump back into the Joby case. We learned all about Joby and Joby's problems. So from factory to flight, let's see how zero bus helps Joby. Joby is able to use our manufacturing agents with Lakeflow Connect, Zero Bus, to push gigabytes of data of telemetry directly to our lakehouse, accelerating time to insights, all with Databricks Lakeflow and the data intelligence platform. So this is a piece of technology that we're helping customers like Joby and Soracom scale. So Zero Bus is helping here to streamline the ingestion for this telemetry data from their manufacturing sites to Databricks. It's eliminating that complexity, but what's really special here is we've given Joby the ability to build these on-prem agents. So Joby has these unique needs that we covered before, that on their factories, every factory is different, every device is different, they have different needs. We've provided them with our Zero Bus SDK, where they've been able to build and support their own agents to maximize local stability and network independence. So together with Zero Bus and these agents that they were able to build and are building, this eases their implementation in a plug-and-play manner. Implementing the on-prem agent can be done in a plug-and-play format on their existing pipelines, so very little needs to change. So this was their architecture before, and now they can run their own customized Joby agent for their needs using our SDK to push data to Zero Bus as part of Lakeflow Connect to materialize this data in near real time into the lakehouse. So I talked a lot about Zero Bus, but now let's see it in action and let's actually build something.
Yeah. Thank you, Iki. So let's do a brief overview. What are we going to do as part of the demo? So we are going to build a performance metrics collecting and forwarding agent, similar to the example Joby had, which Vicky showcased. And once data is in Databricks, we're going to use declarative pipelines to post-process the data. And then we're going to build some dashboard and alerting on top of this data. So let's dive in. Switch to my laptop. Hopefully you see something. We're going to start with a simple Python application, which does basic performance metric collecting from my computer. So let's run it, see how it looks. So you can see it in real time collects CPU usage, memory usage, disk stats, and some network statistics as well. And what we are going to do, we're going to upgrade this application to become this forwarding agent so that we can forward this data to Databricks and scale this app across fleet of devices and build some monitoring of this fleet. So let's stop the app for a second. And before we start changing the app, we need a table in Databricks Workspace. So what I did in advance, I pre-created the table with appropriate schema matching the data I'm collecting. And I'm just gonna run a sanity check query just to confirm that the table exists and that we have some rows there. We have about like 3K rows. So now we can go back to our app. And before we start changing any code, what we need is to generate a proto schema, which matches our Databricks Delta table schema. And it's simple to use this by using zero bus SDK. It's one command to generate this proto file. And now that we have proto file, we need to generate protobuf code. So it's also a single command. And after running these commands, here we can see proto file generated. It roughly, it exactly matches the schema of the Databricks table I created. So let's now go to our app. What we need to do is first import the zero bus Python SDK and create SDK handle. So SDK handle is created by providing server endpoint, Databricks workspace URL, and authorization token. And now we can go to the code of our app. And here we have the metrics collection loop. And below it, we have the looping of metrics collection. So before going into the loop, we need to create a table properties object by using table name and the descriptor of generated protobuf. And then we can create stream by using SDK handle and invoking create stream on table properties. Now we can dive into the loop. Here we have a matrix collection. Here I have the structure I used for my simple terminal applications. I'm going to switch this to protobuf generated structure. And I go below all the metrics. And we don't need anymore to dump this to a terminal. We are going to send it to our Delta table. And how are we going to do it is by creating a record future object by awaiting on stream ingest record command. Now, what this will do is it will, without blocking, just send the record to Delta table. But it will be also good to periodically, for this kind of app, await on the record future and get the ACK back, which means that the data is persisted in a Databricks table. So let's use loop count that I have added and await on record future. So this will confirm that the ACK has been received, and I'm gonna, since I'm taking about 1 second to collect the metrics, I'll do this once a minute. And also for purpose of exception handling, I'll gracefully close the stream and finally close. So now that we are code complete, we can go ahead and rebuild our app. Let's reinstall the new wheel and rerun. So now the app is starting. As you can see, stream is created. And records start flowing. So with each loop, one record is sent to our table. So let's go back where we created the table to our workspace. You can see the count is 3111. Let's refresh. It's now 3115. So it's continuously increasing. Here I have pre-created a continuous declarative pipeline which processes the data, does some filtering, categorization, prepares the data. So I can build a dashboard like this. So let's refresh the dashboard. Here on dashboard, I can see my whole fleet of devices. Besides my laptop, I added my dev machine here. So you can CPU usage over time, we have disk usage over time, we have memory usage, we have network data will be populated, and we have like OS distribution of the device pushing data. And also in my last tab, I have some alerts also that I created. Alerts like prolonged high resource usage, network errors, disk being full, or frequent restart of devices. So now that we have all this, let's come back one more time to our app. It's still sending rows, as you can see, but let's quit for a minute. And let's change code a bit. So let's hard code here that disk usage percentage for this device is 95. So it's like near full disk. So we're gonna mock that my laptop has disk problems. And we are gonna rebuild the app and redeploy, same as previously. Again, app is starting, stream is created, and we are good to go. If you go back, let's go back to our dashboard. Let's go back to disk usage over time usage. Let's refresh. As you can see, dashboard immediately spiked, and we immediately detected that one of our devices has the disk issue. So if you go back, I'll go just for a second, one more time to the app. We have the loop is still going on. And here we see like how fast rows are actually going. Like my logic of my application takes 1 second, and it's like usually 1.01 or nothing to send a row. And the only actual like longer processing that we have is when we wait for ACK, and here it's 2.16 seconds, but it can go like up to 5 seconds, as Vicky mentioned earlier in the slides. So here you go. This is the ACK row here. So we can go back again. If you also, one more time, refresh the dashboard, we'll see like this data continues, like the issue is not resolved yet. And yeah, we can also compare the number of records we have ingested so far. And yeah, we can see like that for all this time we've ingested like 200 new records. And that's for the demo. Okay, switch.
So you got to see Zero Bus in action, but now you're probably asking yourself, like, when can I use it? What's available today? What's coming tomorrow? So today, in the month of June, we are in private preview. We have Azure and AWS support. We support at least once delivery of data, and we have customer-facing SDKs that you can use in both Python, Scala, Java. So you can start building one of those forwarders that we showcased today. Now, the message encoding over the wire is protobuf, so we're looking at maybe expanding that to other encodings in the future based on customer demand. So come talk to us, let us know. And like I said, that we support 100 megabyte per second throughput per one of these connections, so per stream that you open up through the SDK or from a network of collection of devices. And in terms of message sizes, our limit is 4 megabyte size messages that you can send down the wire. So what's coming in the future is expanded cloud support for GCP, an API for exactly once delivery of data, and also a complementary batch file API for larger bulk use cases and lower latency acknowledgement of the data. Now, that's all the service side, but in terms of table features that we support today versus tomorrow, today we do not support schema changes as part of the service, but as a fast follow, we're working on supporting schema changes such as type widening, default value support, and this new concept of a quarantine table so that when we have bad records, we can still make those records durable, but instead we put them into this alternative table. So you can rest assured that your data is durable, but your target table remains clean. So just some final closing thoughts before I let everyone go. That was a lot of information, and you're probably thinking, this is just another ingestion tool. Databricks has a lot of different ingestion tools. We have Spark, we have declarative pipelines, now we have Zero Bus. When should I use one of these? Like, what is the right use case? And I don't think there's any perfect answer, but some guiding questions to help you with the thought process is what I want to leave you with today. So we have the question of what is your data source? And when you think about your data source, what makes more sense? Would you rather push data from that data source? If you're pushing data, Zero Bus makes a lot of sense. If you need to pull data from a data source, maybe an alternative solution like Spark is the right choice. Who needs to consume this data is another one. So do we have operational consumers as well as analytical? A lot of the examples that I gave today of architectures only had analytical consumers of the data, and more specifically, the only consumer of the data was for ingestion. So if you only are using this message bus for ingestion, Zero Bus could be a really good alternative architecture. Also, how many consumers of the data do we have? A single or multiple? If you have multiple consumers of the topic on the message bus, and some of those are operational applications, then maybe it makes sense to keep that message bus around and having this replication pipeline through declarative pipelines or Spark. And the other question is, who is the data operator? Do you need to have real time? Is near real time support enough? Like I mentioned today, as part of Zero Bus and its direct write API, we support 5-second latency from sending the message to them being able to query the data. But if you need lower latency than that, maybe this is not the right choice, at least for now. And then also the other point I want to make here is about customization requirements. What kind of customization do you need to do? Zero Bus today does not do any transformations of the data, and that is by design. What we've built is purpose-built compute specifically to streamline ingestion from source to sink. And this is why we don't add transformations in the pipeline. So thank you all for coming today. That's the end of the talk. This is the last talk on Lakeflow Connect that was part of the schedule. I want to urge everyone to go on the app and fill out the survey. Let us know that we did really well. And if you have any questions, come meet us at the front by the stage, and we're happy to talk more. Thanks, everyone.